Ever feel like you're just drowning in information, trying to grab onto the really important bits?
Oh, absolutely. We get it. You want the core ideas, but without getting lost in all the details.
Exactly. And that's what the deep dive is really all about.
Yeah. Think of it as your personalized shortcut. You give us the source material, articles, workshops, whatever, and we help pull out the essentials, the practical stuff, the aha moments.
And for this deep dive, you sent over some really interesting material. It's recordings from a video workshop.
That's right. Focusing on getting started with programming, specifically Python, for designers.
People using Grasshopper and Rhino.
Exactly. And we've got the briefing docs, too, even a translated version, so we can really get into it.
Okay, so our mission then is pretty clear. Distill this workshop down.
Find the crucial bits. We want you to walk away with the key concepts, the skills, and how it all connects back to design work.
All right, let's dig in. Where do they start?
Well, first off, the instructor points everyone to a website they've set up. Sounds like it's the main hub for everything. Materials, files, web examples, a central place.
That makes sense. Keeps it organized rather than digging through emails or something.
Yeah, like a good design system, right?
Yeah.
Everything in its place. Then they bring up GitHub.
Ah, GitHub. So for anyone not familiar, it's basically like cloud storage for code, but more.
Kind of, yeah. It's a code repository.
Mm.
But it's huge for collaboration,
Yeah.
tracking changes, version control, basically.
Like version control for design files, but for scripts.
Exactly. And the instructor really focuses on the practical bit.
Right.
You can bring that code and use it.
Right. They mention cloning.
Yeah, that's like making your own copy to work on. And GitHub Desktop gets a mention too. Makes it a bit more user-friendly.
Okay, so you've got the code. Where do you actually run it?
Good question. They talk about Jupyter Notebook first, calling it an interactive IDE.
Like a digital sketchbook. Code, results, notes, all together.
Precisely. It's great for learning because you run bits of code, see what happens immediately. Very hands-on.
But not everyone uses Jupyter, right?
Right. So they also suggest Visual Studio Code, or VS Code, which is super popular.
And you can run the same Jupyter files, the .ipmb files, inside VS Code?
Apparently so.
Mhm.
Offers flexibility, lets people stick to an environment they might already know.
Nice. Any other resources?
Yep. Colab is mentioned, another platform for running the examples, good for working across different machines.
Okay.
And a big shout out to Kaggle.
Oh, yeah. Kaggle's huge for data science stuff.
Definitely. Packed with notebooks, data sets. If you want to see how Python's used for data tasks, it's invaluable.
Got it. So that's the map of resources. Now let's get into Python itself. The fundamentals. Data types first.
Yep. Strings, that's text. Integers, whole numbers. Floats numbers with decimals.
And assigning them to variables. They gave that example. G-string, which is assigned to variable string. Bit confusingly phrased, but the idea is clear.
Haha. Yeah, maybe a bit. But it's fundamental. Text, numbers. Programming is all about manipulating different types of data. Python treats them differently.
So like a layer name in Rhino might be a string.
Exactly. And a circle's radius could be a float for precision.
And how do you check what type you're dealing with?
Ah, the type function. Simple enough.
Yeah.
But they make a good point about nested functions.
Right. The inside one runs first, like finding the type of my string in their example.
Yeah, order of operations is key. Gotta know how Python reads things, works from the inside out. Helps with debugging later, too.
Makes sense. Okay, then basic math, plus, minus, multiply, divide.
The usual suspects. And they stress operator precedence
Yeah.
using parentheses.
Like in school math, PMEMs or whatever you called it. You need brackets to control the order.
Totally. Python has its own order. Brackets override it. Avoids those why did I get that answer moments.
They also showed integer plus float gives you a float, right? Like 5 plus 0 becomes 5.0.
Yep. Floats tend to win in mixed calculations to preserve precision. And they introduced augmented assignment operators.
Oh, the shortcuts, like plus.
Exactly. Instead of x plus 1, you just write x plus 1, cleaner code.
Nice. And comments. The humble hashtag, why do we need comments?
Ah, the instructor asks the group, right? Why? Computer can't understand.
Yeah. They're for humans.
Absolutely. Notes to yourself, notes to others, explaining the why behind the code, super important.
Okay, now strings again. They're described as ordered sequences, like arrays.
Yeah, that's a good way to think about it. Each character has a position, an index, starting from 0.
And you use square brackets to get a specific character. The hello world example.
Classic. And negative inboxing too, counting from the end. Surprisingly useful sometimes.
You can also stick strings together with plus concatenation.
And repeat them with multiplication.
Basic text manipulation tools.
Totally. Used all the time for building messages or formatting output.
Then typecasting, changing types, right? Int, float, Gula.
Yeah, converting between them. Essential if you get data as, say, text, but need it as a number for calculations.
They mentioned casting 0, 1 to Boolean. How does that work?
Well, that's a good example of why explicit casting matters. A non-empty string like 0, 1 might seem truthy, but bool 0, 1 actually evaluates to true, but bool 0 would be true, while in 0 is 0 and bool is false. So context and explicit conversion are key.
Gotcha. Okay. Making decisions. If, ill, if, else.
Conditional statements. The core of logic. Is this true? Do this. Otherwise, is this true? Do that. If nothing else, do the else part.
Using comparison operators equals not equals, greater than, less than.
Right, and logical or to combine conditions, they have that A versus B comparison example.
Yeah, printing different things based on the result lets your code react differently.
Makes it dynamic. Then loops, doing things over and over. For loops first.
For iterating through sequences, like numbers from range.
Exactly. Range 5 gives you 0, 1, 2, 3, 4. The loop runs once for each. Super useful for repetition.
And the modulo operator % for finding remainders, like checking for even or odd numbers.
Yep, number % too. If the remainder is 0, it's even. Simple but powerful. They also briefly mentioned nested loops.
Loops inside loops. Okay, you could see that for creating grids of things in Rhino, maybe.
Definitely. Then there are while loops.
They keep going as long as a condition is true.
Right, but you need to be careful. The instructor warns about infinite loops.
Use break as a safeguard.
Always good to put a safeguard like a break, yeah. Absolutely critical advice. A break gives you an exit route if needed.
Okay, shifting gears. Organizing data. Lists.
Yeah, lists are the main focus here. Ordered collections.
Yeah.
Store lots of things under one name.
And you access items using the index, just like with strings. Square brackets again.
And grabbing a portion of the list. Very flexible.
Now, Grasshopper has its own data structure, right? Trees.
It does, yeah. Hierarchical. The instructor prefers lists for this intro, but flags that you do need to understand how to get data out of trees if you encounter them in Grasshopper.
Makes sense. The core idea is accessing data within a structure.
Exactly. Whether it's a flat list or a nested tree, you need to pinpoint the data you want.
So how does this Python stuff actually connect inside Grasshopper and Rhino?
Well, there's a specific Python script component in Grasshopper.
Okay, so you just drop that onto the canvas.
Pretty much. And that's where you type your code. It's the bridge.
And to make Rhino do things, like draw points.
You use a library called RhinoScript syntax, usually imported as rs.
Got it. And examples were r's add point.
Yep, creates a point. And r's point coordinates to get the xyz of an existing point.
And this is key. Rhino objects, like points, often show up in Python as lists.
That's a crucial connection. A point's coordinates x, y, z are literally a list. So index 0 is x, 1 is y, 2 is z.
So you can grab the y coordinate directly. The quote was, "This point itself is a list. From there, I accessed x and y. It means y is 8.6.
Exactly. It treats geometry as data you can index and manipulate. That's powerful for data-driven design.
So if you understand lists and indexing, you can start manipulating Rhino geometry programmatically.
You got it. And the workshop shows how to replicate Grasshopper components using this knowledge, like the series component.
Recreating series with Python loops.
Yeah. It helps you understand the logic behind the visual block. You're generating number sequences programmatically.
They also covered replicating the domain component for dividing ranges.
And remap. They really emphasized remap.
Remap is, you use it a lot.
Yeah.
Remap is very important. For normalization, right?
Normalization projection. Taking values in one range and scaling them to another. Super useful for controlling parameters with data.
Makes sense. What about adding some randomness?
The random module.random.random gives you a float between 0 and 1.
Okay.
And random.randint gives you a random whole number in a range you specify.
And you can scale those, like multiply the 0 to 1 random number to get points in a bigger area.
Yep. Random will give a random number between 0 and 1 and multiply by some range. Good for adding variation. Organic patterns.
Simple functions like min and max were mentioned too.
Quick ways to find the smallest or largest value in a list. Basic data exploration.
And splitting lists, accessing elements, general data handling.
Essential stuff. Plus, a quick look at try, except for error handling.
But with a warning.
Yeah, handle errors gracefully, but don't use it to hide bugs you don't understand. Debugging is still key.
Okay, shifting focus a bit. The instructor really hammered home the importance of practice, didn't they?
Oh, yeah. Repeatedly. You must type, "This is training."
And I expect that you guys can create all the example I showed today without cheating. Yeah.
Yeah. No cheating. But seriously, typing it out yourself builds muscle memory. It's active learning, way better than just watching.
They also talked about computational thinking.
Right. My computational thinking is about splitting things up. You have to look at it simply.
Breaking problems down.
Exactly. Into smaller, manageable steps. That's core to programming and just problem solving generally.
And reading code carefully, line by line.
So you need to look at the order very importantly. Where the execution happens is also important. Understanding that flow is crucial.
Makes sense. They also encouraged using all the resources, the website, GitHub, Colab, Kaggle.
And paying attention to hints in the code editors. And realizing that Grasshopper components often are just code functions underneath.
That's a good insight. Demystifies it a bit.
Yeah. And again, RhinoScript syntax is your key for Rhino interaction. The whole workshop is framed as being about handling data.
And that learning takes time. It's incremental.
Definitely. You build it up, which leads to the minimum expectation.
Right. What's the baseline for passing?
The absolute minimum is creating code to do something with Rhino commands using RhinoScript syntax. That's the minimum. Using the basics, talks fors, loops, conditions, lists.
To do something geometric in Rhino via Grasshopper Python, that seems achievable.
It sets a clear goal. And finally, encouragement to ask questions, learn from each other.
If you guys have any question, asking each other and learning each other, collaboration.
And consistency. It's impossible to cram this.
Yeah.
Accumulated by sound of a tap, setting aside an hour or two every day.
Can't cram coding, gotta practice regularly. Okay, so wrapping up this deep dive then. We covered accessing resources, the absolute core Python stuff types, variables, operators, conditionals, loops.
Introduced lists for organizing data, saw how Python plugs into Rhino and Grasshopper with RhinoScript syntax,
Recreated some Grasshopper logic in Python, touched on randomness and error handling.
and really underlined this need for hands-on practice, computational thinking, and just consistent effort.
It feels like understanding these foundations really opens up a new way to think about design, doesn't it?
It absolutely does. Automation, data-driven forms, exploring complexity, it's a powerful toolkit to add.
So here's something for you, the listener, to think about. Pick a simple Grasshopper component you use often, just a basic one.
Yeah.
And based on everything we just talked about, loops, lists, conditions, maybe errors, functions, just try to imagine how would you build that component's basic function using Python code.
Interesting exercise.
Maybe even grab one of those workshop examples and type it out. See what clicks. It might just unlock some new design avenues you hadn't considered before.